Here's another 1D kinematic problem that we didn't get to do in class. So this is another example of one object catching up to another. A bird is flying straight down at 2.40 meters per second. You're standing on top of the CN Tower, which is 553 meters tall, holding a rubber ball. You release the ball just as the bird passes you. How fast will the ball be traveling when it passes the bird? All right, so let's start by just drawing a little picture of what's happening. So here we are on top of the CN Tower, which is 553 meters tall. And down here it would be the ground. So at the very top we've got a ball which we're holding. So I'm going to draw that here. This is my ball. And then it says that you release a ball just as a bird passes you. So at the same moment, you've got a bird at the same position. Okay, so now the ball is falling down and the bird is flying down. Okay, at some point, the ball is going to catch up to the bird. So the bird is flying down at this constant speed. It gets to some position, and the ball is going to eventually catch up to that bird and get to that same position at the same time. So let's write down all the things that we know. So the ball is starting off. It tells you that you release the ball. So that means it's starting off at rest. So the initial velocity is 0 meters per second. It didn't tell you that you threw the ball. You just released it. You let go of it. So it started off at 0 meters per second. The ball is falling due to gravity, so the acceleration due to gravity is always 9.8 meters per second squared, and it always points straight down. So that's why we're going to put a negative sign in front of it. Okay, let's move on to the bird. So the bird still begins, it tells you the bird is flying down at 2.40 meters per second. So that's the initial velocity of the bird, 2.40 meters per second. But it just tells you that it's flying straight down at that speed. The bird's flying, not falling, so it's not falling due to gravity. It doesn't have that acceleration of negative 9.8. It's just flying down at that constant speed of 2.40 meters per second. So since the speed is constant, we know that the acceleration then would be 0. Okay, so be really careful. If something is falling, it will have the acceleration of negative 9.8 meters per second squared. But if it's flying at a certain speed, it won't have any acceleration. We're assuming it's a constant speed. All right, since the bird is flying downwards, though, we need to be careful because we're saying upwards is positive, so that means down is negative. So we need to remember to put a negative sign in front of the 2.4 meters per second. Okay, so the initial velocity of the bird is negative 2.4 meters per second because it's pointing downwards. So let's organize all of this in a table. So we have the ball, we have the bird. On the side, I'm going to write down all the variables from the kinematics equations. So I have S initial, so initial position, S final, final position, V initial, the initial speed or velocity, V final, the final velocity, and then we have acceleration and change in time. Okay, so we're going to write down everything we know about the bird and the ball. So we'll start with S initial. So initially, the ball is up here and the bird is up here. And at the end, the ball and the bird are somewhere over here. So when I say at the end, I mean when the ball catches up to the bird. So at some point in between where it started and when it hits the ground, the ball will catch up to the bird. So what's the initial position of the ball? Well, that's up here. So that would be 553 meters. And the initial position of the bird is also 553 meters. The final position of the ball and the bird, we don't know what this value is, but we do know that when the ball catches up to the bird, it will have the same final position. So those two will be at the same value. Okay, now we have the initial velocity of the ball. So the ball, we have just released it, so we're assuming that it started off at rest. So the initial velocity is 0 meters per second. And for the bird, it's been flying at a constant speed of negative 2.4 meters per second. The velocity at the end, the final velocity of the ball, we don't know what that is, but we do know that the final velocity of the bird is still negative 2.40 meters per second because we're saying it's moving at this constant speed, which then implies that its acceleration is 0. Now the ball is in free fall, it's just falling due to gravity, so its acceleration is that due to gravity, which is negative 9.8 meters per second squared. And then for time, we don't know the time that it takes for the ball to catch up to the bird, but we do know that when it does catch up to the bird, they will both be at the same final position at the same time. So the two times will be equal. Okay, so now what we're going to do is take a look at the kinematics equation, which are here, and then we're going to decide which equation should we be using. So we know that the SFs and the delta T's are the same for both the bird and the ball. So we want equations that have SFs and delta T's in them. We also know the V initial, we know the S initial, and we know the A's for both of them. So really we want to use equation number 1. So what we're going to do is we're going to find an expression for the final position, SF, for the ball, as well as SF for the bird. And because those two are equal, we're going to set the two equations equal to one another. Okay, so let's start off with the ball. So SF, the final position of the ball, using equation 1, is equal to SI plus VI delta T plus 1/2 A delta T squared. So we'll plug in everything that we know. SI for the ball is 553 plus V initial for the ball is 0 delta T plus 1/2 A for the ball is negative 9.8 delta T squared. So we'll simplify this a little bit. 0 times delta T is just 0. So we have 553. 1/2 times negative 9.8 is negative 4.9 delta T squared. So that's our final position of the ball. Now let's do the same thing for the final position of the bird. So we're still using equation 1. We have S initial plus V initial delta T plus 1/2 A delta T squared. But now we're looking at the column where the bird is. Okay, so we have SI for the bird is still 553 plus V initial for the bird is negative 2.4 delta T plus 1/2, the A is 0, delta T squared. So because we have 1/2 times 0 times delta T squared, all of that becomes just 0. So that's all gone. So when we simplify that, we just get 553 minus 2.4 delta T. So as we said, when the ball catches up to the bird, that means they're at the same final position at the same time. So that means that SF of the ball must equal SF bird. So now I'm going to put in the equation for SF of the ball over here and SF of the bird over here. All right, so SF of the ball, we got 553 minus 4.9 delta T squared is equal to SF of the bird, which is 553 minus 2.40 delta T. All right, so what we want to do is bring everything all over to one side. It doesn't matter if we bring it to the left or the right of the equal sign. I'm going to bring it all to the right side of the equal sign. So I'm going to be left with 0 on the left side is equal to 4.9 delta T squared. Then I have my negative 2.40 delta T. Then I have my plus 553. And then I'll bring my other 553 over so it becomes negative. So I'll simplify that, and I get 4.9 delta T squared minus 2.40 delta T. All right, so this is a quadratic. We need to use the quadratic formula to solve this because we have a delta T squared term as well as a delta T squared. So let's identify what our A, B, and C are. So this would be my A in the quadratic formula. This would be my B. And then there's nothing here, so that would be a 0. That would be my C. All right, so I'm going to use the quadratic formula, which is I'm solving for the variable delta t, so I'd write delta t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have negative 2.40 plus or minus the square root of negative 2.40 squared minus 4 times a times c all over 2 times 4.9. So I'm just going to simplify this. Negative times negative 2.40 is just positive 2.4 plus or minus. Now I'll type everything into my calculator and I just get the square root of, so I'm just going to type in what's inside the square root sign. So I just get the square root of 5.76 all over 2 times 4.9 is 9.8. Now I'm going to write this out twice, once with a plus sign, once with a minus sign. So with a plus sign, I would have 2.4 plus root 5.76 over 9.8. And with the minus sign, I would have 2.4 minus root 5.76 over 9.8. So now I'm going to type each of these on my calculator. So I have 2.4 plus root 5.76 over 9.8, and I have 0.4898. And on the other side, I have 2.4 minus root 5.76 over 9.8, and there I have 0. So that tells me that there are 2 times where the bird and the ball are at the same position. One of the times is 0.4898 seconds, the other one is at 0 seconds. So what does this mean? So at 0 seconds, do you see how the bird and the ball are both at that same position of 553? So that's why that turns out in my answer. But also we found that 0.4898 seconds, that's how long it takes them to get this final position, and they'll both be at the same position at that time. So that's the time that it takes for the ball to catch up to the bird. It would be that 0.4898 seconds. So I'm going to put that in here, 0.4898 seconds and 0.4898 seconds here. So let's see what the question's asking us. It says, how fast will the ball be traveling when it passes the bird? So now we're just looking at the equations for the ball, and we're looking to find out how fast the ball will be traveling. So what we're really looking for here is the final velocity of the ball when it passes the bird. But now we know what the time is, so we can just use that time in one of our formulas. So we'll take a look again at these formulas right here. So which of the formulas would we use? So for the ball, we know the initial position, we know the initial velocity, we're looking for the final velocity, we know the acceleration, and we know the time. So let's take a look. We're looking for the final velocity, we know the initial, we know the acceleration, and we know the time. So we're going to use equation 2. Okay, so let's write out this equation. So we have, for the ball, we have V final of the ball is equal to V initial plus A times delta t. So the V initial of the ball was 0 plus A, which we said was negative 9.8 meters per second squared, times the time, which we got to be 0.4898 seconds. Now when I times that on my calculator, I get negative 9.8 times 0.4898, and I have negative 4.8. And the units would be meters per second. Okay, so that's the number that I got here. So the question says, how fast will the ball be traveling? So it's not asking us for the direction, it just wants to know how fast it's going. So it wants to know its speed. So its speed would be 4.8 meters per second. The negative sign there is telling us that it's going down, but that's not what the question's asking. It didn't ask for the velocity, because remember, velocity is a vector, and for vector quantities, you need to include a direction. But when it just asks how fast is the ball traveling, that means it just wants to know the speed, and speed is a scalar value. So you just need to give the magnitude. So the 4.8 meters per second is enough. You don't need to say which direction it's going. So now we can just make a final statement. Therefore, the final speed, or the speed of the ball when it passes the bird is 0.8 meters per second. Hope that helped. Thanks for watching.